This is example 11 in section 3.4, equations and graphs of polynomial functions. So in this example, what we have is we have a piece of cardboard that's in the shape of a square. It could also be a rectangle. And we're going to cut out the corners of this piece of cardboard. And when I fold up the sides, it will create an open top box that has a length, a width, and a height. When you cut the corners, the dimension of what I'm going to do is I don't know, is the unknown. So that's why we call it x. So this piece of x all around is a square. So when you cut off the corners and fold it, this would be your height that you're cutting. Now, if I know the full dimension is 10 and you cut off an unknown piece x here and x here, you've cut off two pieces. So that's where 10 minus 2x comes into play. Same thing for this value. You're cutting off two pieces on the side, and that's where 10 minus 2x goes there. Now you have to remember we're talking about length, width, and height, and we're talking about volume. So there's certain dimensions where length, width, and height would not make sense. It wouldn't make sense to have a height of 0 because then you wouldn't have the box. It wouldn't make sense to have a length and width negative. So we know we have to have a positive value. So when you look at x, I know that x value has to be bigger than 0 for this to work. It can't equal 0. But then I have to look at this side, 10 minus 2x. If I say this value has to be bigger than 0, then I'm going to have to solve it to see what are some possible values for x. So I'm going to solve it like an equation. I'm going to divide by -2. When you divide by a negative, the sign switches as inequality. I get 5. So I know that if I look at a number line, I know everything has to be bigger than 0, but everything has to be less than 5. So they overlap in this section between 0 and 5. So I know that when I get my values for x, it has to be between 0 and 5 to make sense. So the question tells us that the volume is 72. So I'm going to write an expression in terms of volume. I know that volume is equal to length times width times height. So I know my three dimensions on the box, so I can multiply the three dimensions, and in expanded form I know I will get a cubic, and then my goal is to factor the cubic. So I get volume equals x. I'm going to FOIL these two binomials, so I'm going to get 20x. Oh, sorry, first of all, skipped a step there. I'm going to get 10 times 10, which is 100, minus 20x minus another 20x plus 4x squared. Then I'm going to distribute the x through the brackets. So I will get 100x, 40x, 100x minus 40x squared, and I will get a positive 4x cubed. So now what I'm going to do is substitute what volume is given to me. So it's 72. And I'm going to rearrange my terms so the highest degree is first. So I'm going to make it equal to 0. So I'm going to get 4x cubed minus 40x squared plus 100x minus 72. I'm going to divide all these terms by 4 just so that the numbers are more manageable. So I get 1x cubed, 10x squared, I get 25x, and I get 18. So now you're back to factoring a cubic, which was the previous section. So we need to look at some possible factors of 18 to see through synthetic which one would work. So you make your list, and I know that 2 will work. So my possible factor of 2, if I substitute it in, will give me 0. Now I'm going to do my synthetic and put my coefficients in of my equation. You drop your first term and you multiply, and then we continue the process. 9, 9 2s are 18, 0 remainder. So this is my new quotient. So we're going to keep going. So my polynomial right now is x minus 2 is a factor because 2 when you sub in gives us 0. And then I have x squared minus 8x plus 9 as my other factor. Now, I know that x equals 2 works, but this trinomial cannot be factored using product and sum. So we have to think about what's another way to solve a quadratic. And from previous course, you remember that you can solve a quadratic using the quadratic formula. So the quadratic formula would be negative b plus or minus the square root b squared minus 4ac all over 2a, and then I substitute in my a, b, c. So I would get negative b, which is negative 8, so the opposite of that would be 8. B squared, so 8 squared would give me 64. I know a is 1, and I know c is 9. All over 2 times 1. So I continue the process of doing my algebra. So I get 64 minus 36. I will get 8 plus or minus, subtract that, I'll get 28. Just to remind you of how to reduce 28, even though we're going to use our calculator, 28 is 4 times 7, so the root of 4 is 2, and the 7 tags. So I got 2 root 7 over 2, which I know I can divide everything by 2 and get 4 plus or minus root 7. Because we're trying to find a length, a width, and a height, x equals 4 plus or minus root 7 is not really going to help us, so we're going to put that in our calculator, and we're going to get 6.68 for one answer, or 1.35 if we plug 4 plus root 7 and 4 minus root 7. Right away, I know I can reject the value of 6.68 because you got to remember x has to be a value between 0 and 5 from earlier statement. So I have x equals 1.35 as a solution. That works. But you got to remember, going back to synthetic, we also remember that x equals 2 worked as well. So how do I find the rest of my values? So if I want to find the length, width, and height, remember what height was. Height was the value of x, so that's 1.35. The 10 minus 2x, which I know was 1.35, will give me the remaining value, which is 7.3. So I know the width is also 7.3. If x equals 2, length, width, and height, then I know height is 2. And if I plug in 2 for my length, I get 10 minus 4, which is 6. So you have two different boxes here that have a length, width, and height, but the volume for both boxes would be 72. And that's it.